supply and demand. So if you're able and interested, please do stick around at that point. But to kick off our afternoon, I'd like to introduce our next moderator, Mr. Aaron McKittrick, who is a Research and Development Officer with the Department of Energy for the Government of Bermuda. Aaron is part of a small but very dedicated team that's responsible for creating energy policy and legislation focused on achieving the country's energy mandate. He also is the project manager for the Finger, which is Bermuda's first utility-scale solar installation out by the airport. Aaron's panel is going to explore the environmental impacts of transportation in Bermuda and how electric mobility can be part of the solution. So over to you, Aaron.
Thanks very much, EJ. Much appreciated. And welcome back, everyone. It's a pleasure to be a moderator today. Thanks to RMI and to everyone else, the Ministry of Transport, of course, for hosting this event. Without all of them, this would not be possible. So I'll be brief. I'll introduce you to our panelists this afternoon, and then I will ask them to go ahead and do some presentations. And then, as with previous panels, we can get into a Q&A session, etc. So our first presenter is Dr. Jeff Smith. Many of you may know he is the environmental engineer who heads up the pollution control section of the Department of Environment and Natural Resources for the Government of Bermuda. With his team, he administers the Clean Air Act, the Water Resources Act, and with the associated regulations, including licensing and permitting, which are some of the primary pollution-related legislative processes in Bermuda. How about that for a mouthful? Joining him from the government is David Peniston, also from the Ministry of Public Works. David is a manager with the ministry. He has previously held positions as a special waste officer, waste management section with the Department of Works and Engineering. His responsibilities include managing the special waste section, which collects the hazardous waste locally from garages, paint manufacturers, local hardware shops, and the government facilities, which includes our favorite, the Tynes Bay drop-off facility, the airport waste management facility, which are then processed and shipped overseas to be recycled. So just to set the tone, while hopefully Jeff is online and can start to share his presentation, as we heard this morning, which was touched on in our first panel, the environmental impacts, obviously, of the transition to electric vehicles or to zero emissions vehicles is obviously critical for an island that relies on tourism and our environment, and selling that environment as part of the tourism package. As most of you probably know, we have a long history in Bermuda of environmental regulations, as Jeff will speak to, and a lot of pride around our early adoption of legislation, of environmental legislation. As talked about, emissions obviously are a big thing when it comes to transportation. Denton Williams mentioned it this morning, or touched on it this morning. And so hopefully Jeff in his presentation can provide us a bit more detail, what he does, what he studies, and what he researches as part of his position. So welcome, Jeff. I'll hand it over to yourself to start your presentation. You may be on mute.
Mute, yes. Thank you for that, Aaron. I'll thank you again, you and the Department of Energy, for the opportunity to present today. Good afternoon, everyone. Can you all hear me now? Yeah, good. Okay. So my presentation today will largely focus on data, environmental impact, ecological data that's associated with largely not using electric vehicles. So this is the sort of the current status quo. So the focus really is the environmental impacts that we're aware of at the moment, which are largely associated with those coming from the internal combustion engine vehicles. Get my slide to work. Okay, so when considering the environmental impacts caused by electric vehicles compared to internal combustion engine vehicles, it's necessary to sort of take into account the whole life cycle, the cradle to grave, if you like, of that vehicle. And it's noted that the environmental impact over that cradle to grave will include sort of greenhouse gas emissions from manufacturer right through to disposal, byproduct pollutants such as nitrogen oxide, sulfur dioxides, also as products of incomplete combustion when these vehicles are in operation. There's water usage to consider, and also damage to the environment where the raw materials are extracted from the ground. But those environmental impacts associated with the manufacture or the mining of fuels or the vehicles themselves, materials for the vehicles, is considered more of a global impact. Obviously, it affects us indirectly, but the focus of the presentation today really is going to be on what we consider to be the immediate sort of local effects, if you like. So we're looking at the any emissions from vehicle operation, disposal of materials from those vehicles, and ultimately the end of life disposal of those vehicles also. So that's primarily what I'm going to focus on today. I've done a little bit of research as when Aaron asked me to present at this presentation, and there is a significant amount of literature that's sort of growing almost on a daily basis that's trying to compare the sort of net environmental impact of electric vehicles versus internal combustion engine vehicles over their whole life. One of the better papers appears to be the US Congressional Research Service paper from 2020, and they've estimated that on the whole EVs are contributing about 33% less greenhouse gas contributions than internal combustion engine vehicles over their life. But it's also important to note that there appears to be a 70% variability in the data, depending on whether you're comparing that data to coal-fired power stations or other types of power stations. More importantly, though, for Bermuda, in a more immediate context, are the pollutants that are sort of generated as a result of operating those vehicles. And this particular study, the US Congressional Research Service, has highlighted that in terms of local pollutants generated, that there is typically 61% less volatile organic carbons from electric vehicles compared to internal combustion engine vehicles, 93% less carbon monoxide, 28% less nitrogen oxides, and 32% less black carbon, which is the soot, the PM10s, the PM2.5s that Denton from the RA mentioned earlier, all of those particles, but also the chemistry associated with those particles as well, which I will go into. I mean, ideally, when you're going to be burning fuels, from our point of view, from the point of view of the pollution control section, we want 100% combustion. We don't want any inefficient combustion. We want as much carbon dioxide if you are going to burn petroleum hydrocarbons. We want as much conversion of those petroleum hydrocarbons into carbon dioxide so that you get less of these byproducts, because it's the byproducts that are giving us the signatures and the environmental impacts that we're observing. So when we monitor what's in the ambient air, the outside air, we abide by the clean air regulations, which are under the Clean Air Act. And within there, they provide limits for human health in terms of what it's safe to breathe in with regards to nitrogen dioxide, sulfur dioxide, PM10s. We're also expanding it at the moment to include PM2.5s, but we already monitor those in all the stations around the island anyway. That's particulate matter. PM10 is particulate matter less than 10 microns in diameter, so about 10 times the size of a bacterium. PM2.5 includes less pollens and more focused on what comes out of a combustion internal combustion engine vehicle. That's less than 2.5 times the size of a bacterium, really, to give you some sort of ballpark estimate. So we monitor the air in 6 locations over the island. When I say we, the Department of Environment will contract the Bermuda Institute of Ocean Sciences to manage air quality stations at Prospect, which is number 1 in the center of the island here. That's just to the south of the Tynes Bay Waste to Energy incinerator. So that's primarily looking at the exhaust from that when the wind is in a favorable direction. And it's been located in a place where the modeling suggested was a good place to look for the emissions when the wind is in a favorable condition. Site number 2 is East Broadway. So people here will recognize that on the drive into town. That's the monitoring station down here that's monitoring all of those pollutants from vehicle traffic specifically. And we also contract the biostation to do a control site in St. George's. Through the Clean Air Act, we also license the electrical generator on the island, Belco, and we condition them to manage, it used to be 2, it's now 3 ambient air monitoring stations on the island. One of them is located at Cemetery Lane, which is this one on the left. You can see right below the tall stacks. In fact, it's designed to measure the impact from the lower stack engines, which have now been in the process, would have been retired and in the process of being demolished. So this site here will be seeing favourable conditions going forward. Site 5 is at the top of Langton Hill, which sees the fallout, really, the emissions from these taller stacks. And since we've had the new North Power Station engines online, we have required Belco to put a new monitoring station at the end of Ocean Lane, where they're seeing some downdrafting of the exhaust over the top of Langton Hill, down the back of that hill. They can't even see the stacks, but they're getting impacted. So we're monitoring there. So we've got 6 monitoring stations, all set up, meeting the standards of the US Code of Federal Regulations in terms of their siting and parameters, located on quite a small island. So that's quite good coverage, really. This is some data now focusing on the East Broadway monitoring station on the way into town, which is focusing on road vehicles. You can see over the 24-hour clock that you're picking up the rush hour from 6 o'clock in the morning, typically, and it's a relatively short-lived peak. It's over by about 9 o'clock in the morning. Then it diminishes somewhat in around midday before you get a more diffuse increase in particulate matters, the blue graph, that's PM10s. And the annual limit for PM10s, by the way, in terms of what it's safe to breathe in over a long period of time of 1 year, is 30 micrograms per meter cubed, so that you can see that the PM10 limit at this particular site is always very close to exceeding the annual limit. The 24-hour limit and the hourly limit is obviously much, much higher. The 24-hour limit is much, much higher, so it doesn't exceed that. But in terms of the long-term exposure, that is significant. The red graph is nitrogen dioxide. The annual limit for that is 60 micrograms per meter cubed. That's on the right-hand side, the scale. So again, you can see what the rush hour vehicles are contributing to what's in the ambient air, the outside air that we breathe. If we look at all of the data, again, I'm just focusing on the PM10, so the particulate matter less than 10 microns. This is the particulate matter that you can inhale into your lung, and it can remain in the lung until it's brought out of the lung. If you look at the data from 2008, which is the graph on the left, through to 2020, graph on the right, for each of the five of the 6 sites, you've got Tynes Bay, the incinerator, you've got the vehicles at East Broadway, you've got Belco Cemetery Lane, you've got Belco Langton Hill, and you've got the control site. You can see generally the higher signals that we see for PM10s in terms of what you're breathing in are at the vehicle site of East Broadway, where there's a lot of traffic there over the rush hours and generally coming into town every day. You can also see that in 2008, 2012, 2017, we actually exceeded the annual limit, which is based on health and safety data at 30 micrograms per meter cubed. Last year, you can see the last graph here I'm highlighting with the cursor was low. We expect that due to COVID. I did one publication in EnviroTalk which showed how those emissions had dropped off once you entered into lockdown, as you'd expect. I'm not sure why the 2019 data is low as well, but we've still yet to look into that. And generally, PM10 is known to cause people with asthma to be a trigger for them to have another asthma attack. And the World Health Organization also state as well that it contributes to all sorts of respiratory and cardiovascular diseases as well. So it's something you want to really keep out of your bodies, the particulate matter. But what's also important is not just the particles themselves that you're breathing into the lung, which are bad for you, which can cause reactions in the body, but is actually the chemistry within those particles. So within particulate, oh, before I get to that, actually, before I distract you. So PM10s are what we're monitoring. We also monitor PM2.5s. And a lot of the international research now is focusing on something called ultrafine particulates, which are typically 100 times smaller than the PM10s. They're down into nanometer sizes. And these particles are so small, they're very difficult to monitor, but some places have been able to monitor them. There's no standards for them yet. But these particles, when you inhale them, they are so small they can actually pass across the lining in the lung and directly into your bloodstream. So those are important as well. So they're sort of captured within the PM10s because it's 10 microns and below, and the PM2.5s is 2.5 microns and below. But really, there's not really many monitoring systems that can detect them because they're so small, they'd probably be considered a gas, or if they're in a liquid, they'd be considered an aqueous phase rather than a particulate phase because they are literally that small. So within all of these particles, we know exist polymatic hydrocarbons. Pyrene is probably one of the most toxic, but you've got other ones there as well. They're basically, as the name suggests, many aromatic rings joined together. These are present in airborne particulates. They're also present from open fires, and they're also present in the char of deep fried foods as well, so beware. We also have dioxins and furans, other indicators in the soot, and the numbers around these particular carbon rings relate to where chlorine atoms can be substituted into these diphenyl organics, giving them, these have quite a lot of toxicity. They're normally associated with NIMBYs not wanting incinerators to be placed close to their houses, but they're actually generated from all combustion processes. There may be more of them generated from incinerators, but there's a small amount produced from each and every vehicle on the island, and that can soon add up, as I'll show in the data. And we also have heavy metals. And I can also share this data, which is currently unpublished. It's data that we've collected. For those of you who are unfamiliar, Bermuda roofs are white, normally limestone manufactured. They used to be limestone washed, and they collect rainwater, and we store that rainwater in tanks under the houses, which is a very sustainable way to exist. But it can come with problems, obviously, because anything that falls on the roof gets washed into the water tank as well. And what we've done is we've basically looked at 3 water tanks that were pre-cleaned, and then we know the roof area of those particular houses that are feeding into those water tanks, and we've worked out over a 2 or 3 year period how many particulates as a flux rate in grams per square meter per month are falling on the roofs in different parts of Bermuda. Woodbourne Avenue is in Hamilton. We studied that. That has on average about 1.1 grams per meter squared per month of particles falling on its roof that gets washed into the tank as sediment on the bottom of the tank. Point Finger Road is by a busy road. It's the southern end of Point Finger Road. It's away from town. That showed 0.23 grams per meter squared per month falling onto the roof. And Lighthouse Hill Lane, which is in a rural setting and absolutely surrounded by lots of farmers' fields, you might expect that to have a higher amount of particles falling on its roof, but it was actually the lowest, an order of magnitude lower than what we see in town. And if you look at the sediments as well that you collect in these tanks, they're very much a dark grey colour in town, and they're very much a light brown sort of soil looking colour in Lighthouse Hill. So that gives you instantly by a visual impression of what we're dealing with here. So excuse the complexity of this graph. It is relatively simple. I'll just explain. These are dioxins and furans. These particular chlorinated organics are generated from any combustion process, and they're very refractory in the environment. They don't get degraded by bacteria. They're not water soluble. They become indicators of where they were generated. And the signature from a mass burn incinerator is the same the world over. We've done many measurements from our Tynes Bay incinerator, and it looks exactly the same as any other mass burn incinerator over the world. So you have a certain signature of dioxins. You've got all the different dioxins on the bottom. The numbers relate to how many chlorine atoms are in there or where the chlorines are located. Tetrachloro diphenyl dioxin. The OCDD is octachloro diphenyl dioxin, so fully chlorinated. And then you've got all the furans here on the right. And these are proportions that we're measuring here of the total dioxins, and we're measuring them in the soils and in the sediments of the tanks. And this was a study we commissioned Biostation to do back in 2005. And we've done many studies since, and the data is always the same. So the signature from, as I was saying, from Tynes Bay incinerator is the same the world over. From Belco heavy fuel engines is the same the world over, and same for vehicles, whether they're gasoline or diesel. They'll have a slightly different signature, but they will be the same the world over. And what this particular study was focused on was, is there any fallout from the Tynes Bay incinerator affecting Bermuda's water tanks, affecting the roofs and the sediment in the water tanks, etc. And the conclusion from this study was, well, first of all, the reason the boxes around the center of the island where the Tynes Bay incinerator is, are the dioxins and furans higher here? Well, yes, they were. They're an order of magnitude higher. But if you look at the proportions, they were exactly the same over the whole island. and they were the same in the soils and the same in the sediment of the tanks, as you can see with these signatures here, the red, the yellow and the orange graph. Incidentally, in the water, all of the data that we've done, even data that's been collected this year, we've always shown that the water is safe to drink, so that these pollutants want to remain in the sediment at the bottom of the tank. They're very insoluble in water, so that's an important conclusion as well. But if we compare the signature in Bermuda's soils and tank sediments to what Tynes Bay generates, which is the blue graphs, you can see it's very, very different. I put the blue graphs on a different scale on the next axis, just to compare. So the sediments don't show any signature, even if you're right next to Tynes Bay incinerator. It still shows the same signature here. It was very low variability over the whole study. However, if you compare it to what you see from this is gasoline vehicles, the green bar charts, you can see there's some similarity here. This isn't data that we've collected in Bermuda. It's quite complex to do a dioxin analysis. It costs many tens of thousands of dollars, and we just literally relied on what's available in the international literature. But it is the same again the world over. But you can see here, and it was certainly the conclusions of the study by BIOS, was that the dioxins and furans that are present in the sediment and thereby indicating the presence of other organics associated with the soot largely reflects a vehicle origin over the whole island and not that of Belco. Even with the recent Belco issues with the new North Power Station engines, those analyses of all the soot falling on people's roofs there from some unfortunate recent episodes that are being in the process of being corrected, there was no Belco signature there over and above what was seen as the vehicle signature in the sediment of the water tanks. And we're seeing the same signature in the sediment of the water tanks, in the soils, in the stormwater soakaways sediment there, in the ponds of Bermuda, where we have some unique species, in Pembroke Canal, which is a road runoff receiver from Hamilton, and also in nearshore marine sediments by roads as well, where they also receive runoff. They all reflect a vehicle origin, a vehicle source. Oh, sorry. Okay, so the dioxins and furans are very much the indicators that tell us that the vehicles are the source of these pollutants. Other pollutants associated with the soot particles from the vehicles are polyaromatic hydrocarbons. And in there you've got naphthalene, which is your mothballs, that's the most volatile, up to pyrene, chrysene, various anthracenes and so on, very polyaromatic hydrocarbons as the name suggests. And these are present, as I mentioned earlier, in Bermuda's ponds. We identified the cane toads, which are actually an invasive species from the States, but they've been here for many, well, a few hundred years, I believe. They're considered a critical group. They live in the ponds, they're within the sediment of the ponds. So if anything is going to be affected by these pollutants within the ponds, within the sediment of the ponds, it's going to be these species. And I've been, well, coming to Bermuda and now living in Bermuda for the last 11 years, but I've been coming here for over 30 years. And just the decline in toads on Bermuda's roads is phenomenal over that period. It's very rare to see any now, whereas certain times of the year before, they were everywhere. You're always having to drive really slowly just to avoid them. The population has been in drastic decline. The responses in these particular species has accounted for birth defects, endocrine disruption, and various cancers and tumours. In fact, we sponsor Dr. Jamie Bacon at the Bermuda Zoological Society, sometimes known as the Toad Lady. She's very good at what she does, and she's basically shown all of these effects. And we also work very closely with Doug Fort of Fort Environmental Laboratories in Oklahoma. And what he was able to do was to basically complete controlled experiments using the same concentrations of polyaromatic hydrocarbons that we have in Bermuda's ponds, with controlled species from the States of cane toads that you have in the States, also killifish and also red-eared slided terrapins that we have here also, and was able to recreate those same birth defects and same tumours and so on in these particular species. In fact, Dr. Jamie Bacon, for a lot of these toads, she's very experienced looking at these and dissecting them and so on. She can't even tell whether she's looking at a male or a female of the adult species because of the endocrine disruption is so bad. So there is a definite effect in this critical group. Obviously, we don't live in the ponds, in the sediment of these ponds. So that, you know, potentially there is a warning there. But this is basically an indicator a canary, if you like, in the coal mine of what the effects of the exhaust from internal combustion engines have been on the island of Bermuda. I'd also like to touch on disposal considerations. Both our department with the Environmental Authority license under the Clean Air Act all sorts of controlled plants on the island. We license about 600 types of polluting plants, and the government waste management facilities includes those plants as well. The airport waste management facility by the airport, obviously, is an inert landfill for receiving all of the construction waste and the the incinerator ash concrete blocks, in addition to a lot of the metal waste on the island. The metal waste is on a short-term approved list in the conditions of that operating license, but it's been on that short-term approved list now since the early 1990s when the legislation came into being. Public Works have tried to export the waste internal combustion engine vehicles off the island, but it hasn't been successful to date. So before an internal combustion engine vehicle it can be disposed at the airport facility into this marine infill that is within Castle Harbour, it has to be drained down, has to have all the oils and the fuels and the hydraulics removed, which are then managed separately by that Sallyport Hazardous Waste Facility, and David Peniston is presenting next on that and other facilities in government. The batteries are removed as well, and is then placed into the marine infill. So what I would add in terms of vehicle disposal considerations specific to electric vehicles here is ignoring the batteries, taking the batteries out of the electric vehicles. I would say that the environmental impact of disposing the electric vehicles, which would be a worst case scenario in such an infill, has got to be a lot better than the existing practices of disposing the ICE vehicles at the moment at that facility. So I have yet to determine what the environmental impact of the electric vehicle battery disposal is. Ideally, we don't want to dispose of them. We want them to be recycled or reused or whatever. And obviously there's various different polymers and ions used in that. So that environmental impact study is yet to be completed. So this is the last slide. But in accordance with the sort of the environmental waste management adage, you want to reduce before you reuse, and then ultimately, if you can't do that, you need to recycle it before you dispose of it, if all else is lost. Obviously, any underperforming electric vehicle batteries could very easily be used as photovoltaic stationary storage. We've heard already how batteries in some countries are already being plugged into their houses. Not just for when the power goes out, but you can do that as well into the evenings. If you don't need 250 miles range on your battery the next day, and we're on an island that's very small, then certainly you could use some of that battery recycling, charging in your household in the evening. So, but any underperforming batteries that are no good for your vehicles would certainly have a use, I would imagine, in Bermuda as a stationary storage use on land next to a house. And if you are going to recycle them, then I believe a lot of work needs to be done in terms of improving how electric vehicles can be recycled. At the moment, they're not as recyclable as lead acid batteries. We do license two private companies on the island, very small companies, private individuals who do export lead acid batteries off the island in addition to ballasts and heat exchangers, and they make a living out of that, which is good because it saves government having to dispose of those. But whether the global markets can make electric vehicles more recyclable, we've still yet to see, but that would be a preferred option to get the batteries recycled off the island. If it isn't financially viable to recycle the batteries, then the options will be local disposal once the environmental impact is understood, or potentially export by government, obviously at a cost, but there's a potential to levy that cost on the disposal on a purchase price of a new vehicle, an EV or a new battery potentially. So I think that concludes my presentation.
Thank you very much, Jeff. That's fantastic. Great detail. And I'm sure there'll be lots of questions to come, if not today, then further on from your presentation. So quickly, I will hand over to David Peniston, who I just introduced a little earlier. With 10 minutes to go, David, if you can please share your presentation, and we look forward to hearing it.
I'll cut it from 10 to 2. Thank you.
Okay, good.
So as was stated, yes, I'm representing the Ministry of Public Works, our waste management team. that deals with actually recycling and of course the shipping away of special or hazardous waste. So Alan Douglas is our material recovery officer. He works at the MRF, which is our materials recovery facility for recycling all of the tin and aluminum and steel that comes through the recycling plant. Me, on the other hand, I deal with all the waste chemicals, and we try to ship all those overseas. What cannot go into our landfill at the airport dump or here at Tynes Bay. So we try to ship all of those overseas to a vendor who then tries to recycle those things. And of course, our mantra is reduce, reuse, and recycle, as Dr. Jeff brought out. So in our presentation, let's see if I can share the screen here. So here we have our what our end of life for the EV batteries. So we know that eventually we will get, as waste management, those batteries coming to us. So some of the things we're concerned about is the storage, the packaging, cost, and the shipping regulations. So when it comes to storage, we're looking at the end of the viable vehicle life. We know that most people that are making these as distributors are saying that these vehicles have an 8 to 10 or 12 year life cycle on that battery. But we do know, as Dr. Jeff brought out, that we have a viable issue of on-island reuse, and that could be used in the solar panel installations where these batteries can be used for storage of solar energy. So it has some potential where these batteries will not be discarded into our facilities, but be used in other potential areas. But then we are looking at what happens if they come to us. Well, it's going to eventually require us to dispose or recycle them. And of course, because they're lithium-ion batteries, most of them are lithium-ion, there is rules and regulations governing the recycling of those. When we look at them being imported, they're rather packaged by the manufacturer. They arrive in cold storage. And of course, we know that these, because they're being used in vehicles, have to be impact resistant. And so most of the vehicle importers will bring those in via the manufacturer's recommendations on how to keep those batteries until they can be reused in an EV vehicle. But for us, what about the individual batteries that are now taken out and they're waiting to be exported? What is the risk? Well, there's chemical spills and explosion. We know that the chemical in there is lithium. It's very explosive. You've probably seen those smaller batteries, like in a cell phone that's been punctured, explode on YouTube. So that gives you some of the risk. And we know that these batteries are way bigger and hold a lot more charge. Some of these are looking at 72 kW. I think one manufacturer has in his battery, 72 kW of power. And you think about that exploding or getting off, it's very detrimental to the person in the vehicle plus whoever is working on as a mechanic or the disposal plant that will be dealing with it. So what do the manufacturers recommend? Well, store these batteries in a cool, dry place. You know, Bermuda's not cool, maybe dry, but it's very humid here as well. But that's the manufacturer's recommendations. Then we're looking at who is it going to come, who's going to be the responsibility of dealing with these at the end of life. Is it going to be us as waste management, or is it going to go back on the vehicle importer? So that is something that is, I guess, going to be thought out as we make the policies for dealing and disposing of these. Right now, there's at least 2 importers who send their batteries back to the manufacturer at their own expense. So 2 companies that are bringing in, they are recycling their batteries back to their manufacturer. What is the packaging requirements? Well, individual batteries that we export to the US is regulated by the DOT hazardous materials regulations. Those US regulations are equivalent to all the international standards that Dr. Jeff may have mentioned in his presentation. We know that they're class 9 because they're a lithium battery, and we must label them for shipments, which is mandatory. So that will be on the battery itself, in the container that it's packaged in, and then on the container on the outside, and has to have the labeling on the manifest when it's shipped out. And these labeling requirements are, in addition to the universal waste or the hazardous waste for damaged batteries, which are labels which are also required by the EPA. These lithium batteries must be packaged to prevent short circuiting, movement within the outer packaging, and accidental activation. So when we're looking at an EV battery, these batteries are not small. They're about the size of a desk and 8 inches thick. Most car manufacturers are making the little floor chamber of the car is the battery. So if we think about the size of the cars coming in, that's quite a large battery per vehicle. But those will require to be packaged the same way as we do right now our household lithium batteries that we do and send back and forth. What are the costs associated? Well, some cost will be towards the dealers. Well, these dealers are mandated to bear the cost of returning batteries to manufacturers. Most EV car manufacturers' batteries are proprietary to that vehicle. So the dealer will probably be mandated by the manufacturer to send back to their manufacturing factories for recycling. That's a big savings to the Bermuda government to send that back. But what is the cost to government if we now get the end of life of this battery? Well, right now the cost to send an electric vehicle battery to the US is $1,432 per container to be shipped from Bermuda port to the US port. If we ship that same battery to Europe, it's $5,500. So we can see the benefits of recycling in this type of vehicle battery to the United States, because it would reduce our shipping costs, and then we may be able to make some sort of money back off of the electric vehicle battery during the recycling process. Well, what are the regulations? Well, EV battery shipping and the regulations are, as we read, they're monitored under the size of the battery. So right now, the EPA and the DOT have regulations that cover the small batteries, which are the consumer type batteries that you'll find in a watch, or maybe like a power tool. There's LiPo or Li-Fe batteries. Those are the ones they're talking about. And they come under that regulation 49 CFR 173.85C for brackets. But any damaged ones, as you can see, so that will be a normal battery. It's reached its end life and it's still in good condition. But what happens if they're damaged or defective? Well, then a whole different regulation comes into portion, which is 49 CFR 173.185F. And these are now classified as hazardous waste. Each cell or battery has to be placed individually into a non-conductive packaging. So if you can imagine, each one now, if they're damaged, now has to be placed into or repackaged. What that entails on our side is that we have to tape the conductive ends on each battery. So if you think we've got 10,000 batteries that are lithium, that's 10,000 individual wraps that we have to now do. The inner packaging must be packaged according to the PG1 rated container secured with non-conductive material to prevent movement. So these containers have to be impact resistant as well, that we ship them in. And then it also has to have a non-flammable packing core. So basically we're layering in this drum that we're shipping the batteries. So we put a layer of non-conductive material, then the batteries, non-conductive material, batteries, all the way till we can fill it. And but it also is regulated by how much pounds. And right now, the regulation states 75 pounds. So all we can put, including the weight of the barrel, is 75 pounds. So it's not much that we can actually get into a drum. So we're actually trying to ship them out in smaller packaging containers. And of course, we have to mark it with damaged or defective lithium ion battery or lithium metal battery. So these are the different things that we're doing. What it states now, right now on the medium and large scale, EPA recommendations is contact the manufacturer, automobile dealer, or company that installed the Li-ion battery for management options. Do not put in the trash or municipal recycling bins. So right now in the United States, their regulations is that the manufacturer, you have to contact them for recycling of those EV batteries. And because of that, you know, the size and complexities, these may not be able to remove by the consumer. So it would have to go back to the manufacturer, and the manufacturer's instruction to the mechanics who will be repairing or dealing with these vehicles would have to heed all the warnings and instructions given. Says for energy storage, because we know that's the automobile, under energy storage, we'll contact the energy storage equipment manufacturer company that installed the battery. So the solar company, BE Solar, or one of the other ones that installs this unit into your home application, you would have to contact them. That's right now, it's the regulations governing the United States. Of course, what are the shipping regulations continuing? Well, right here locally, Renault and BMW, the manufacturer's policy mandates that these EV batteries be returned directly to them, which requires cost of shipping out of, obviously, Bermuda. We mentioned those costs, what they are. Kia and Toyota, there's right now, there's no manufacturer battery return policies. They are in the process of both those companies putting something together. But currently, what can we do? Well, we can research, and we are researching on-island reuse, and then obviously our overseas disposal or recycling options. So we have those available to us. So that pretty much wraps up what waste management's, and as things go on and we put the policies together, according to our EPA regulations through DENR, but then also because we're required to follow the overseas mandate for shipping and disposal of these recyclable batteries, this is a policy that will be put together once it becomes mandated through the EPA of the USA and also through DENR. Then we'll pass that on to all the vehicle manufacturers and how we'll be shipping and handling these recyclable EV batteries.
Excellent. Thank you very much, David. Again, very, very informative and detailed information. So should be no doubt in people's minds, you know, the work that you have to go through and the steps you have to go through and Jeff has to go through in regard to your jobs and dealing with vehicles, recycling, emissions, etc. So thanks again. We've run out of time for this panel for Q&A, but we have seen some questions come into the chat, which is fantastic. We can possibly answer those this afternoon in the breakout sessions. But again, I would just like to thank our panelists, Dr. Jeff Smith and David Peniston, and I will turn it back over to EJ to lead us into our next panel. Thank you.
Thanks so much, Aaron, and thanks to the panelists for that great conversation. Really appreciate it.